Okay.
Do you hear me? Yeah. Okay. Hi, everyone. My name is Mutlu from the University of Wisconsin-Madison. The topic that I want to cover is kind of builds on everything else that has been talked about today, and takes it to more, what happens when these applications are envisioned and prototyped and sometimes deployed, and how do they actually take it out to the real world? That's sort of the broader topic I'm in. But today in the presentation, I want to give you a flavor of the range of applications, the broader range of applications that they are envisioning. They have prototyped, they have shown proofs of concept, and where they're going with that in terms of deployment. And my hope is in the actual chapter, we're going to have more information about technology transfer models and standardization and such. One of the things that really stuck with us was how much they were, the labs that we visited and researchers were integrated with industry. There was almost no lab that didn't have, at least in Japan and Korea, that didn't have some connection to industry, or in terms of funding, in terms of technology transfer, and things like that. One lab that we went to in Korea, ETRI, actually, they said that they just simply don't publish. And their success is measured by the products that they're deploying, technology transfer. And a good part of the lab's income actually comes from royalties from the products that they commercialize. So these countries, from this perspective, have a very broad vision of we really want to take robotics, take these core technologies, find problems that we as societies care about, apply these technologies there, and see if these things work, that we can put it out into the real world. So I want to cover a few things about what are the different models in which people have presented these to us, what is the broad range of targeted applications are. That's going to have some overlap with the previous presentation. And then at the end, I'll talk about sort of the end tail of that, how much of that have become real-world applications and what we might be seeing in the near future. So we saw a number of different paradigms in which people presented their work. One was robots as agents. The idea here is that robots are autonomous characters, agents that have their own goals that are in line with the user's goals, but they are acting autonomously, helping people out, but they do not rely on people to complete tasks, do their assistive tasks. The shopping assistant we saw earlier here again, they help people, they go around, find the person to help, they know the environment. All of this is done autonomously as sort of agents making decisions about what they should be doing. Another paradigm we saw was more sort of a synergistic approach with people. So these are robots that extend human capabilities that are useless without the human there, and humans sometimes, in certain cases, don't have the capability if the robots are not enabling them. For example, we saw educational robots where, in Korea especially, the ETRI robot there, the telepresence robots would be sent to a rural area, and the English teacher would be in Seoul, or it would be in the US, and interact with kids that way. So here, the teacher is not actually physically present to do the teaching. Therefore, these systems are extending their capabilities into reaching out. The example that we saw earlier, the robotic room, they also call it the sick room. Basically, there are people who would like something to be fetched, but they don't have the ability, or would like something to be brought to them, organized, and the robotic systems are enabling them to do so in this case. A number of systems that we saw and labs were focused on was this idea of robotic control. So you have robots around you that are designed to complete specific tasks, and you provide them with commands on what to do. And the research really focuses on, how do I control these robots? Do I tell them, hey, go do this? And what are the different innovative ways that they could be doing this in? Manuel talked about these examples before. These two examples are really interesting. One of them is, let's say that a robot has to set the dinner table. The user would take a picture of the ideal arrangement that they have for a particular dish, and the robot would know that picture and go find all the dishes and bring them together, set it in the way that picture is describing. So this idea of giving a high-level novel command in a novel way is something that this lab is extremely focused on. The same thing with the robotic fan. How could the user input into the fan how it should be, blowing air? This is not even a problem that we talked about, but if there is a robotic product in the future, there has to be some aspect of control. Users have to provide some input. This is a way that they've devised. Users will do that. One other thing that was very unique, and we were really impressed with some of the labs there, were this idea of robots integrated with the environment. So it is extending the capabilities of the environment. It's really not this embodied robot